So welcome to this class. This class we'll be looking at how to name this skeletal structure for the compound alkene. So how do we know that in alkene the presence of the double bond here? So the first thing was going straight to the point, as we already know, to name any organic compound, we must be using our formula, which is the prefix or prefixes, when we have like multiple substituents there, plus root plus what then? Suffix. And the reason why we are not having suffixes is because suffix denotes the parent name, and we can't have two parent names, hence it's just suffix, but we can have multiple substituents, hence we have prefixes. Now the next thing is to be getting each one of them before we actually join them together. Now the first thing is to get our roots. Now, if we are to get our roots, we are to get the longest continuous carbon chain there. And whenever we are dealing with alkene, we have to give preference to the double bond here, the numbering that actually gives this double bond the lowest number for the carbon atoms. Now, if you count from here, if you say you are considering the forward numbering, we have 1, 2, 3, 4, 5, 6. Now, for skeletal structure, each edge here represents carbon atom. This man here, carbon atom here, carbon atom here, carbon atom here. So the double bond, when we are considering this forward numbering, is between carbon 4 and carbon 5. If you are considering this backward numbering here, 1, 2, 3, 4, 5, 6. We can now see that the double bond is between carbon 2 and carbon 3. Hence, we go for the what? Backward numbering. And to get our root, we know that our root is a number of carbon atoms present in the longest continuous carbon chain. Hence, we have our 6 carbon atoms present there, and that is X. And the suffix. Now, we already know that the suffix is the parent name, that is the functional group that acts as the parent name. And from this structure here, we already know that the alkene has double bond here. Hence, our suffix is going to be, instead of, for the case of in, this case is what? In. So we have what? In as our suffix. Now, this is where it becomes more complex. We have to denote the position of the double bond. Now, we are considering the backward numbering because the double bond has to have the lowest number there. Hence, the double bond is between carbon 2 and carbon 3. And whenever you have the double bond between a lower number and a higher number, you are going for the what? For the lower number. Hence, we have to say it is what? 2 in. Denoting that the double bond there is attached to carbon 2. So the next thing there is to get our prefixes. Now, prefixes. We already know that the prefixes is just the substituents. And from here, our longest continuous carbon chain is this man here. This man here. Hence, we have 2 lines coming out from this carbon. We are considering this backward numbering. Hence, this is carbon 5 here. So we have 2 lines attached to carbon 5, and that 2 lines represent methyl each, because this is 1 carbon atom here, this is 1 carbon atom here. And we can now say the first thing we have to do, in this case, that's where we have for the case of ditri. But for this case, we have 2 methyl group attached to the carbon 5. Hence, we can say we have 5 dimethyl. That's just the 5 dimethyl. Why? Because this carbon 5, we have 2 methyl group attached to it, and we have this here. So we can just have our sub prefixes as what? 5 dimethyl. So that's just the concept, because it's attached. You have 2 carbon atoms, the one here, and they are both methyl. Then you have your di here, and even we have 3, which is what? Tri. So that's the concept there. Now, using the formula, joining everything together, we write our prefix first. So we have the IUPAC nomenclature as, what do we have here? The prefix, we have what? 5,5-dimethyl. Then the roots. What will be our roots? This one here. And I already told you in the last class that the number and letters has to be differentiated with an hyphen. So hence, this is not, there is no number here, so we just have to write our x there. So in small letter we have H-E-X. That's our root. Then the next thing is our suffix. Now, because we are dealing with alkene, you have to tell us the position of the double bond. Hence, we have what? 2 in. That's where we have, it is 2 in. To join this to this x here, it is number that is here. So we have to put the hyphen first. Before writing this 2, then we put our in. And this gives us the IUPAC nomenclature for this particular compound.